On May 22, 1960, the ground in southern Chile did not shake suddenly. It moved for minutes, longer than people believed the Earth was even capable of. Buildings collapsed, coastlines shifted, and the shaking did not feel violent at first. It felt slow, heavy, and impossible to escape. By the time the motion stopped, the planet itself had changed shape. The earthquake had released more energy than any measured before or since. What happened in Chile was not a random act of destruction. It was energy that had been stored underground for centuries, finally released according to physics. Earthquakes are often described as sudden shaking, but the motion we feel is only the final moment of a much longer process happening deep underground. Long before the ground moves, energy has already been accumulating in silence. The Earth's crust is divided into massive tectonic plates that are always moving. Their motion is slow, measured in millimeters each year, but it never truly stops. This movement continues even when the surface feels completely still. Where two plates meet, their edges do not slide freely. Friction locks them together, preventing motion while forces continue to build. The plates keep pushing, but the boundary refuses to move. As the plates continue to push, energy does not disappear. It is stored inside the rocks themselves, bending and deforming the crust like a compressed spring. The ground absorbs stress instead of releasing it. This stored energy can remain hidden for centuries. At the surface, everything appears stable and unchanged. Below, stress continues to accumulate, slowly approaching a physical limit. This behavior is known as elastic strain. The rocks along the fault deform under pressure instead of breaking immediately. Energy is stored quietly as the crust bends, but does not yet fail. Rocks are strong, but they are not infinitely strong. Each fault has a mechanical limit determined by pressure, temperature, and material strength. When that limit is reached, resistance can no longer hold. At that moment, the locked plates begin to slip as stored energy is released suddenly, converting deformation into motion. What was held for centuries is discharged in minutes. The ground shaking we feel is not the cause of the earthquake. It is the consequence of energy moving through the crust as seismic waves. These waves carry the release outward from the fault. The larger the area that slips, the more energy is released. This is why major earthquakes are not defined by how hard the ground shakes locally. They are defined by how much energy was stored and how much was freed. Energy release does not happen at a single point. It spreads along the fault line, breaking rock over hundreds of kilometers. The longer the rupture, the longer the shaking lasts. This is why duration matters as much as intensity. Long earthquakes exhaust structures and the ground itself. Even well-built systems struggle when motion continues without pause. In large subduction zones, faults can remain locked for centuries. During that time, tectonic motion does not stop. Energy continues to accumulate beneath the surface. The longer energy is stored, the greater the potential release. When failure finally occurs, the scale reflects not 1 year of movement, but hundreds of years combined. This is what separates great earthquakes from ordinary ones. They are not sudden surprises. They are the final release of stress that has been building quietly over generations. In subduction zones, one tectonic plate is forced beneath another. This motion does not happen smoothly. Large sections can remain locked while pressure continues to increase. Along the coast of Chile, this locking occurred between the Nazca Plate and the South American Plate. Convergence continued year after year, even as the boundary itself refused to move. As the plates pushed together, energy accumulated across an enormous area. Stress was not confined to a single point. It spread along hundreds of kilometers of the plate boundary. When failure finally began, it did not stop quickly. The rupture propagated along the fault, releasing energy section by section. The Earth adjusted itself in stages, not in a single break. This combination of long-term accumulation and large rupture length defines the most powerful earthquakes ever recorded. Chile in 1960 represents this process at its extreme limit. On May 22, 1960, southern Chile experienced the largest earthquake ever instrumentally recorded. The rupture did not occur at a single point, but across an enormous section of the subduction zone. The fault began slipping near the coast and continued southward for hundreds of kilometers. This length alone explains why the shaking lasted far longer than most earthquakes people had experienced before. What made this event exceptional was not just its magnitude, but the amount of energy released. Centuries of accumulated tectonic motion were discharged in a single sequence of rupture. As the plates adjusted, sections of the coastline permanently shifted. Parts of the land were lifted, while other areas subsided, reflecting how deeply the crust had been deformed before failure. These changes were not side effects. They were direct evidence of energy storage and release on a planetary scale, confirming the mechanism scientists describe when the ground stores stress for generations. The shaking did not end when the rupture stopped. The ground continued to oscillate as seismic waves traveled through the crust, carrying released energy across vast distances. Because of the earthquake's size, these waves propagated around the globe. Instruments thousands of kilometers away recorded motion caused by stress released in southern Chile. This global detection confirmed how much energy had been stored before the rupture. The planet responded as a connected system, not as isolated regions reacting independently. The duration of the Chile earthquake was not an anomaly. It was a direct result of rupture length and accumulated stress being released over time rather than instantaneously. In this event, the ground did not simply break. It adjusted itself, redistributing energy that had been locked into the crust for centuries. Large earthquakes are often described as sudden and unpredictable events. In reality, the release may be sudden, but the process leading to it is long and systematic. Tectonic plates are always moving, even when no earthquakes occur. What changes is whether that motion is released gradually or stored as energy beneath the surface. This is why quiet regions can still produce the largest earthquakes. A lack of recent activity often means stress is accumulating, not disappearing. Earthquakes are also misunderstood as isolated events. In truth, they are part of a continuous cycle of motion, resistance, storage, and release. When this cycle is ignored, earthquakes appear random. When it is understood, their behavior becomes clearer, even if their timing cannot be precisely predicted. Earthquakes are often remembered for how violently the ground moves. But the true story begins long before that motion is felt. The Earth does not release energy without warning. It stores stress slowly, quietly, and consistently, following physical rules that never stop applying. The Chile earthquake of 1960 was not a failure of the planet. It was the inevitable release of energy that had been building for centuries beneath the surface. Across the world, different faults store energy in different ways. But the process of accumulation and release remains the same. When the ground finally moves, it is not acting without reason. It is responding to limits that were reached long before anyone felt the shaking begin.